Hi everybody, welcome to my second video introducing you to SVG, Scalable Vector Graphics. This is part 2, Positioning in SVG. So who am I? I'm Rob Larsen. I'm an experienced front-end engineer, author, and open source contributor. I'm the co-author many years ago of Professional jQuery, the author of Beginning HTML and CSS, the author of The Uncertain Web from O'Reilly, the author of Mastering SVG, which is, of course, topical, and co-author of the HTML and CSS workshop. I'm also a longtime open source contributor. I currently maintain HTML5 boilerplate and administer the H5BP organization on GitHub, as well as many other open source projects that I contribute to. What we'll cover today. So, SVG's user coordinate system. Then we'll talk about the SVG viewport. Then we'll define and discuss a little bit user units. Then we'll discuss the very interesting and powerful SVG Viewbox, and then we'll do a small demo manipulating the Viewbox so you understand what it's all about. So, the SVG user coordinate system. Here we go. So, to move forward, we introduced SVG in the last video. To move forward from there, we're going to take a step back and look at the fundamentals of positioning SVG elements. In the first video, we talked about using X and Y coordinates to position an element in an SVG document. There's more to it than that. So let's define what we call the SVG user coordinate system in detail. Here's an example document. As we learned in the first video, SVG elements use a coordinate positioning system to position elements on the screen. By default, 0, 0 is the origin and is located in the upper left-hand corner of the SVG element. The plane continues infinitely in all directions. Elements in an SVG document are positioned using X and Y coordinates relative to that origin. If you're a web developer and you're used to working with CSS, this will be familiar to you. It's like working with absolutely positioned elements. The only difference in SVG is that there are two different attributes used to place elements on the plane. This example illustrates that. As you learned in the first video when we introduced the circle element, the CX center X and CY center Y attributes are used to define the center of the circle. Here we're going to introduce the rect element for rectangle. So in this newly introduced element, the X and Y coordinates are applied in the X and Y attributes, and they define the upper left-hand corner of the element. In other words, placing a rect element, which uses X and Y, is the exact same as absolutely positioning a div in an HTML page. Same thing, except you just do it in line as opposed to in CSS. So there you go. And let's illustrate that for a second. Here's coordinates in action. The gray area just shows you where the outline of the SVG element is, the one we just showed you the source code for. The origin is 0, 0. The center of the circle is 150 and 100 pixels. And the upper left-hand corner of the rectangle is 250 and 50. So 50 from the top, 250 from the left. So now let's talk about the viewport. On an SVG element, the height and width attributes define the viewport of the SVG document. In this case, it's 400 pixels wide and 200 pixels high. The viewport is the visible canvas of an SVG element. As we just learned, the dimensions of the underlying SVG document can be much larger than the viewport, but the visible area is defined by the viewport. In this case, again, 400 by 200. And this is where things get interesting. Now, if you just set the height and width attributes of an SVG element and don't use the viewbox at all, or just set it to correspond, as in this case, to exactly the 0, 0 origin with the same height and width, in this case 400 and 200, as the underlying image, the coordinate plane in your SVG element will actually behave just like CSS. In this case, the coordinate system will start with the coordinates 0x and 0y and will end at 400x and 200y. So in this case, and we're going to introduce a new term here, each user unit will default to 1 pixel on the screen. So from 0 to 400, 0 to 200, they're pixels. It's exactly like CSS. But you might ask, what's a user unit? Let's define it and show some examples. In SVG, user units are an abstract, dimensionless unit fundamental to how SVG elements are rendered and scaled by the browser. By default, one user unit is equivalent to 1 pixel, meaning that any numerical value specified without a unit identifier in SVG, while technically is a user unit, it's actually just a pixel. Things can get interesting, though. While the initial coordinate system uses these user units that are equivalent by default to system pixels, the Viewbox attribute on the SVG element can establish a separate user coordinate system, allowing for scaling, panning, and zooming of the SVG content relative to the viewport. This effectively changes what one user unit represents visually without altering the underlying numerical values. This is very powerful. So what you can think of is the viewport and the height and width are equivalent to what the HTML document, the surrounding HTML document sees, or they define for a standalone SVG element, they define the default behavior of the SVG document in terms of like embedding it in a web page or whatever. And then the view box you can think of as the internal map that the SVG engine uses to render the SVG document. Let's take a look at what that looks like. So now we'll talk about the view box. I'm going to use a few different examples to illustrate what it actually does. To start to understand how this works, let's ask, what happens if you double the size of the viewport by doubling the height and width attributes of the SVG element, and then change nothing else? What happens? So in this case, we've increased the width and height to 800 and 400 respectively, but we've kept the view box the same. So the coordinates of the view box are 0, 0 for the origin, and the height and width are 400 and 200. We've kept the same center X and center Y of the circle, the same X and Y of the rect element. So what's going to happen? And I'll show you. This example, as you can see on the right, shows the original document that we've been working with, the original SVG, and then we have the 2x version. So it's 800 by 400, and as you can see, it scales perfectly. So if you double the height and width, it doubles the viewport size to 800 by 400, and the image scales accordingly. Since the view box and all the underlying coordinates remain the same, the image scales up naturally. Remember, since the rendering of SVG elements happens in the browser and is calculated based on the instructions in your SVG document and not predefined pixels like a JPEG or PNG, this means that you can double the size of an image or quadruple it or whatever just by changing the height and width, and it will scale up perfectly. This is one of the best things about SVG. Let's play with the Viewbox a little bit to give you some examples of how it works. And before we get started, I've talked about it, but let's make it explicit. The Viewbox attribute has got 4 properties. It's the X coordinate, the Y coordinate of the origin, and then the width and height of the document. So in this case, which we'll see in a second, we've adjusted the Viewbox, we've adjusted the XY 25 pixels to the positive, but kept the same height and width. And we'll see in a minute what that means and what that looks like. In this example, we adjust the view box in 3 different ways. The first image is the baseline. The origin X and Y are set to 0, 0, and the height and width of the document match the SVG element's height and width. So it's 400 by 200 pixels. The second image offsets the image by negative 25 pixels. So the origin of the second document is negative 25 and negative 25. And as you can see, it pans the document up and to the left. The third image offsets the image by a positive 25 pixels. So you can see it pans the document to the right and down. The fourth image does something that's very interesting. It sets the origin, as is in the original document, to 0, 0, but changes the viewbox height and width to half of the intrinsic image size, 200, 100. So what this does is it effectively scales up the underlying SVG document. Remember, all of the calculations are the same, but because the intrinsic height and width is half, but the actual rendered height and width is the full one, you've in fact doubled the size of the rendered document, even though the viewport remains the same size. And this is what we talked about, being able to zoom in. And the alternative is you can zoom out. I'll now show a real-time example of how this works. But I think that's one of the more interesting things, because you wouldn't necessarily think about the way that that works unless you see it in action. So let's just take a look at the source code real quick. This is the baseline image. As I said, the Viewbox is 0, 0 for the X and Y of the origin, and then 400 and 200, which match the width and height of the image, 400 and 200. Pretty straightforward. So here's the positive 25 unit offset. And as you can see, this one, the height and width are the same, 400 by 200. So the viewport is 400 by 200. The view box is 2525, which pushes the origin down and to the right, but it still retains the original 400 by 200 height and width. So it scales, it doesn't scale it at all. It just adjusts where the origin starts. And then in our example, moves the circle down a little bit and to the right. This one is the negative 25 unit offset. So we go up and to the left. The height and width are the same, 400 by 200. The view box is negative 25, negative 25. So that's the new origin. And the height and width remain the same, 400 by 200. And all of the code, the rest of the code for all of these elements is exactly the same. So all we're doing is manipulating the view box, which changes the way that the document renders in the browser. And finally, here's the example where we have the 50% viewbox height and width, which effectively doubles the size of the rendered images. So here we have the same height and width for the viewport. The viewbox is set to 0, 0 for the origin, but then the height and width are set to 100 for the height and 200 for the width, which, as you'll see in a second, effectively doubles the size. This illustration shows us how the changes we've seen in the markup for each of these documents changes the way each SVG is rendered in the browser. Remember, both shapes are defined in exactly the same way in each of these elements. The only thing that we're changing is the viewbox definition. Here's a small demo showing how adjusting the viewbox works. If you want to check out the source code, it's very simple, but it's on GitHub. All we're doing here is rewriting the viewbox attribute of this SVG document by manipulating some strings. That's all. Very simple. But what we're going to do here is we're going to bring off-screen content into the viewport. And you can think of a use case for this where if you have a visualization and you have something that's happening in the viewport now, but you may be updating something off-screen, you can just adjust the view box to bring that off-screen content into the viewport and show the user very quickly without having to render anything new or calculate anything new. You can show the user whatever content or whatever visualization you've done off screen. And you can continue to do that. And you can also click and drag and all sorts of things. So this is very powerful. This is a simplified example of it, but it shows what happens. So what we're going to do here is adjust the X coordinate of the origin to 300, the Y coordinate to 100, and then the hidden content comes on screen. And then we'll just show you quickly that it's pretty easy to real time pan content just by adjusting the view box. And you can imagine doing much more complicated things than this, but at the end of the day, it's the same mechanism. You just change the X and Y coordinates of the view box, and this element moves around pretty smoothly. What we've learned. So what are the key takeaways? First, SVG uses a user coordinate system, and that's defined by the height and width of the image and the values in the viewbox attribute. Secondly, we learned, and this is important, adjusting the height and width of an SVG image and nothing else scales the image up perfectly. Third, adjusting the view box can pan or zoom an SVG image very simply. Thank you. Like I said, this is the second video in this series introducing you to SVG. In the next video, I'm going to be talking about some new SVG elements. Now that I've done this kind of not deep dive, but more detailed introduction into the coordinate system, we're going to talk about the elements that we can place on that coordinate plane and things we can do with them. So I'm going to go through probably 3 or 4 SVG elements every episode for a while, introducing them, talking about what you can do with them, talking about the tricks and tips and traps and some of those sort of things that I've learned over the years. And we'll get you up to speed on using SVG elements over the next few episodes. I get some links on screen, my blog, which is revitalizing after a few years, GitHub, which has been very active for the last 15 years, my LinkedIn, which you can find me on there. You connect there if you want to. And the code and slides for this are on GitHub. All these links are in the description as well. If you haven't yet, please subscribe, like, drop a comment. I really appreciate everyone that's checked this out so far. I know this is a new channel, but it's a lot of fun for me. And yeah, I'll see you in the next one. Thank you. Bye.